All right, hello everyone, and thanks for attending. My name is Jeff Catlin from Edgecore Networks, and this presentation is going to go over some open hardware designs that are either upcoming or currently used in ONF reference designs. So I'm from Edgecore Networks, and my company is a networking supplier who's been very active in OCP, ONF, and the telecom infra project for the past 5 or 6 years. So it's my pleasure to present this information to you. So the first thing is, what are open hardware designs? So in my mind, open hardware designs are designs that are contributed to an open source community, right? And this could be OCP, which is the majority of the open hardware designs, or it could be the telecom infra project as well. These designs can differ in the amount of information that is contributed to the community. They could be the specification only, and in this situation it would be, for OCP, it would be an OCP-inspired design. So in that situation, the actual design files are not publicly available, but a detailed specification of that design is available publicly. Ultimately, it would be an OCP-accepted design, which means not only is a detailed specification contributed and publicly available, all of the design files are available. And this, as was gone over in the last presentation, is everything from Gerber files and schematics to the source code for the CPLDs and the likes of. All of that information is made publicly, and that's put on the OCP website, available for download from anyone. You don't have to be a member of OCP. You can just log onto the website and download the design package. Okay. And as far as interaction with ONF, at least with Edgecore and our OCP open hardware designs, we've been interacting with ONF now for 5 years. In ONF Designs with our OCP hardware designs and associated software components that go along with that. So this has been a long, ongoing relationship between OCP and ONF for these hardware designs. So not something new. So the designs that I'm going to touch upon today, not specifically the designs, but where OCP and or TIP type designs are used today, are in these ONF projects. And one common theme here from most of these projects, at least 4 of these projects, is Trellis. So I'm sure you've heard about Trellis and what that is. And that's a common theme throughout 4 of these. Where these designs are used, and the last one is the ODTN, or the Open Disaggregated Transport Network, and there's an open design used in that ONF design as well, which we'll kind of touch upon. So again, the Trellis, what is Trellis? The common piece that's used throughout all these ONF designs. Well, it's a leaf and spine fabric design for the networking portion. It includes on the top of that an ONOS controller from ONF to control those networking nodes, applications on top of that controller. Down below those networking switches are compute nodes and or storage nodes in some situations, and networking devices that provide access onto the network, onto that Trellis building block. So this is a building block that, again, is consistent throughout 4 of the ONF reference designs, and where a lot of these common open hardware designs are used. Okay, so kind of looking at Trellis, a bit further, where are these open designs used at the different spots within Trellis? Okay, so we have this leaf spine architecture, and of course switches are used at those levels. Historically, for the Trellis design, the generic Trellis design, those have been more data center centric type switches through OCP. So the associated silicon that goes along with data center centric switches. Again, there's the compute nodes that's down below those switches, and the box on the right there is representing where the network access would be. And again, that's access through maybe GPON or G.fast or Metro Ethernet access, or access for this pod to connect upstream into the internet cloud somewhere. And so those are kind of the three areas where open hardware designs are used today in the ONF reference designs. So switches. There's a long list of switches that are suggested by ONF today. So this is a scrape off the ONF suggested BOM for Trellis as far as switches. So highlighted here in the green are the OCP either accepted or inspired designs are what's listed here. So again, for switches for the Trellis network, there's everything available, you know, from 1 gig switches all the way up to, of course, now there's 400 gig switches available through OCP. So all of those types of switches are available to create a Trellis architecture from various vendors that are listed up here. The vendors that are listed in green, of course, have gone the extra step and contributed their designs to OCP. So that's why they're highlighted in yellow. Okay. And of course, some announcements here at ONF Connect have been around Stratum. So it's a new lightweight network operating system for switches that has been developed with ONF, through ONF. And again, there's support for switches in Trellis that run Stratum, so you can have a mixed environment of switches in a Trellis environment that run either OFDPA or that run Stratum, and that's all taken care of on top of the switches by, you know, the ownerless controller and applications that run on top of that. So here's a list of those switches that are suggested and have Stratum support today. So there's 2 different ASIC tracks that are supported today and various vendors that supply switches for Stratum today. Again, the ones highlighted here in green have kind of, the vendors in my mind actually have gone the extra mile and actually contributed their designs to OCP and got OCP accepted status, which again means specifications and complete design containers for that. Okay, and as far as Stratum, there's you know, additional switches that are soon to come. I didn't put them up here because they're not available today, but those include other silicon offerings, including Mellanox and Cavium and some other silicon that's right on the horizon for Stratum support as well. So what runs on these network switches that make up this Trellis leaf and spine architecture? Well, a lot of that software actually, the low-level software comes from OCP. Open Compute. So at the you know, starting very bottom of that stack and working up, I guess. Of course, there's a you know, BIOS that's included on that switch, and OCP is working on standardizing on some open source BIOS in the future that would be required on OCP submissions. Then there's the bootloader. That's the generic loader that goes out and looks for a network operating system to load on the switch. So this is a key part in these open switches. This is the piece of functionality that allows this disaggregation between the hardware and the software with this ONI installer. Any network NOS that is available for this switch and supports the ONI install operation can be downloaded on these open switches. So you can buy a generic piece of hardware. If it supports, you know, a NOS compatible of ONI for this switch, you can have this piece of hardware and download different network operating systems at your leisure on top of the switch. One step on top of that generic bootloader and download for the switches is Open Network Linux. So there's a Linux distribution that's through Open Compute called, you know, Open Network Linux, and that's available on all of the OCP accepted networking switches as well, and that's just a generic distro that's there to build upon for different functions. Also in that switch package for the Trellis environment is a Redfish API. So Redfish is a standard through the DMTF for low-level hardware management, supported by most servers and storage nodes today, and this is an OCP thing as well. So all of the OCP accepted switches, at least from Edgecore, and I think those other vendors listed up there, now all support a Redfish API for hardware management. So now you're starting to get a consistent view of all your hardware in your Trellis environment, not just the networking gear, but also the servers and the storage. Now you can manage all of that under one common API and management platform. For the interface to the controller, today that is through OpenFlow, and most of that is through Broadcom-based switches with OFDPA, which is an abstraction on top of their ASICs for OpenFlow programming. And with Stratum, of course, now there's another way to program those switches through other generic interfaces, and there's support for Stratum-based switches today in Trellis as well, as we've seen here in other presentations. So the software package for Trellis is made up of these basic building blocks, and then vendors have the ability to put other value-add functions in addition to these in that software package as well, if they'd like. But this is the standard building block for those Trellis-based switches. Sure. Yep. Correct. Yes. So the question was, is OFDPA or OpenFlow the standard interface that the controller talks to the switches on? Right? And the answer is yes, that is correct. And the controller in the generic Trellis environment is ONOS. There are other controllers that could be used, but OpenFlow data plane abstraction. Yeah, yeah. There's other, just to be fair, there's other OpenFlow implementations that ride on top of non-Broadcom silicon, so such as Barefoot has a OpenFlow implementation that's supported by Trellis. It's not OFDPA per se, but it supports TTP or table type patterns in OpenFlow, which is the key for Trellis and ONOS. Okay. So OCP switches available. This is a scrape off the OCP website, and this is just to show that how many different switches, even though they're not on that generic BOM, are available as open hardware designs that could potentially be used in a Trellis environment, provided they supported that generic software package, which is fairly easy to do. So there's many switches that are available through Open Compute. From various vendors and various performance capabilities, ranging from, again, 1 gig to 400 gig with low-level x86 Atom class processors all the way up to very high 8, 16 core Xeon class processors on some of these designs as options. So the full range of switches for a Trellis environment is supported within OCP as well. In that Trellis environment, of course, we head off to the right. The access into that Trellis environment, or the access of the network for either consumers or enterprise customers or what may be. So there are OCP accepted switches, of course, or PON devices, aggregation devices that are in use today in SEBA, in the SEBA ONF design. And the first one is used in Trellis, which is a Metro Ethernet type switch, which is an OCP accepted contribution. So this supports the types of functions you would think on a Metro Ethernet switch: high QoS, deep buffering, the likes of high route table can take a whole route table type of thing. Normally these are based on a piece of Broadcom silicon, Broadcom DNX. So those are available. There's access devices for residential customers as far as PON today. So there's a couple OLTs that are OCP accepted that are used by ONF SEBA today. So there's a XGS PON OLT, 16 ports of XGS PON, and then there's a 64-port GPON OLT. Again, those are all OCP accepted devices used in either Trellis or SEBA today. So much like the OCP networking group page that showed all the different switches that were available today, here's a scrape of the OCP Telco working group page, okay? And this shows all the potential either devices that are available today, like those PON devices and Metro Ethernet switches that we just talked about, or specifications that have been contributed to OCP, waiting for design partners to develop a product. So there's many specifications out there for G.fast and the likes of other things that have been submitted by the likes of other carriers such as AT&T that are awaiting product development. There's new specifications out on the OCP Telco websites for newer GPON OLTs, so higher density XGS PON OLTs will be coming on the horizon also from OCP. So you expect a lot more telco type products coming from OCP that will fit into these existing ONF designs that are available today. And again, compute nodes, so the compute nodes that are used in the Trellis environment, there's an OCP-inspired design that's, again, on the suggested BOM for the Trellis environment, and this is a Quanta compute node, and the characteristics are listed here. Again, on the OCP website for either server or storage, there's 40+ options available, so if this OCP inspired design does not suit the needs of a Trellis environment that a customer has, there's many, many more open options that are available to customers to suit their performance needs. So this is just one of many that's available, and the one in use today, or the suggested, is OCP inspired. So I just wanted to touch upon the different groups in OCP. So there's 10 working groups and then subgroups underneath them. So there's many opportunities for other types of technology from OCP that could be leveraged by carriers in their ONF types of designs. So again, there's networking, there's a telco group, there's servers, there's storage, there's rack and power, there's firmware groups, there's all kinds of activity going on in OCP today, so a lot of different opportunities for technology still on the horizon coming from these groups. So a couple examples, simple examples. So this is a carrier-grade rack that was developed in the OCP Telco group. So this is a rack infrastructure that defines, the power, excuse me, and the cooling for this rack. It also defines full and half-width sleds that would go into this rack, and then the data interconnection and top-of-rack interconnection between all these sleds in a rack. So, there's OCP racks that are available for telco or carrier use today. Going a step further, there's data centers, portable data centers that are defined in OCP. So you can go to the OCP website and there's specifications and there's vendors that will supply these types of modular data centers that can be dropped on site for a carrier if they need to build out more capacity at their cell tower or where they're doing their hubbing spots if they need something. So there's single data centers and there's modular data centers that go up to 300 kilowatts. So those types of things are available. So OCP spans the gamut from 1 gig switches that are OCP accepted all the way up to modular data centers that can be dropped on site and deployed. So, interesting stuff. And the last slide here, although this isn't an OCP accepted design, this is a design that Edgecore, my company, although we're very active in OCP, we put this design through the Telecom Infra project. So I show this here for a couple of reasons. One, it's relevant to the ONF work that's going on because this is a platform that's part of the ODTN project. So this is a packet transponder, so it has 16 ports of standard 100 gig interfaces in the center, and then on either side of those 16 100 gig interfaces are 4 ports each, so 8 ports total of coherent optical ports. So this, is takes optical transponders to the next level where there's switching and routing capable within that device, and it's an open architecture. So in this design, one of the software packages available here is made up of all OCP components. So that's why I included this here as well. So it supports, of course, the basic ONI installer in this as far as the software package, Open Network Linux, supports the Redfish API for management. This supports Sonic as the switching NOS for the switching side of the house. This NOS that's listed here supports an open config interface that talks to the ONOS controller. So now ONOS controller can talk to this and configure the coherent side of this device as well. So it can configure the launch power and the modulation and all those other parameters on the coherent optical ports. So this shows all three communities starting to come together here and work together. So not only is it very powerful when you have a community working together within itself, now we start to see all three communities, ONF, OCP, and TIP coming together to provide complete solutions for products that go out into the marketplace. Okay. So next steps and follow-ups I put on this slide, not the last slide. So, my call to action here is if you're a carrier and want to get involved in OCP and define your product needs, and there'll be vendors there that can work with you to help bring that product to life. That happens every day, and that works very well. If you're a vendor, such as Edgecore or other, participate, right? Participate in OCP and ONF and get your products through. If they're a hardware product, get them through OCP, get them contributed. Again, they don't have to be accepted. That's preferred in my opinion, but they can be OCP inspired, right? You don't have to contribute all your design specs if you're not comfortable with that. But the thing is, get involved. And if you're an integrator, choose products, or if you're a consumer, if you're a carrier, choose products that come from a vendor that participate in these communities and that contribute their products through OCP. So on those charts that had the products for switches and compute nodes and whatnot, now there's many options that are not OCP contributed, but if there is an option that is OCP contributed, select that option, because that vendor has gone the extra mile to help propel and push this open source movement forward. And the link here is for Open Compute in the products page, where I think that's for the marketplace, where you can search on any type of products that's available through OCP, and it will come up with a list of available vendors for you. With that, I thank you, and that's the end of my presentation. I would take some Q&A.
Yeah, questions? Here. Yeah, as long as the vendor has the certification, if one of the value propositions or one of the articulated value propositions of ONF is commoditization and white boxes, should a customer care between your solution and any other quote-unquote white box ONF certified solution? What is the differentiation, or does it not really matter? Or are all of you guys equally good, equally bad?
Well, I would like to think it matters, because I come from a vendor that does that. But there are differences, even though there might be, I'd like to think there are differences. There might be designs that are very similar, so there might be two 100 gig switches that are available, right? Same port count, they look the same. One might have a different type of CPU architecture that the customer is looking for. Maybe one has an Atom class processor, or one has an ARM processor, or one has a Xeon processor, depending on the compute power they need. Maybe one is more efficient in its power designs. That's very important to these carriers and data center operators and the likes as well. So power efficiency is another one. Maybe one vendor is more active and supports more of the software functions on top of their switch, like that Redfish API or other plug-in modules that can go into Open Network Linux and help them manage their infrastructure. So I think there are differences in the approaches vendors take. But again, I think part of the key is, if you're going to select a product, at least select one that's through the open source community, if possible.
This is a question for both you and Bill Carter, sitting in front of me. Could you go back 2 slides where you showed ODTN, which I think is, I'm guessing, open
disaggregated transport network.
Is
To the best of my ability.
Yes, that's right.
Is that what it is? Okay.
That's correct.
Yeah. I wish all speakers would define these new acronyms on their slides, so I wouldn't have to ask these frequent clarification questions. But here's is my question. There seem to be 3 prominent open source organizations that are specifying hardware for telco networks: ONF, OCP, and TIP. Then there are a whole bunch of secondary and tertiary that are focused to specific market segment, like Open RAN and CBR Alliance and so forth. And they're developing.
ONF is not one of them, by the way. ONF never specifies any hardware. It just uses OCP or TIP hardware.
Okay, I didn't know that.
All right.
Thanks for that clarification. What I'm wondering is, how do these open source hardware organizations, let's just take that, how do they coordinate? Do they have liaison statements? Do they have joint meetings? You mentioned on this project, it was a joint effort of OCP, ONF, and TIP. So how do you all coordinate? I know how that works in the standards world, but I have no idea how it works in the open source consortium world.
All right, I'll let Bill answer that. I didn't mean to say that the three organizations work together on this project. Okay, actually Edgecore worked together with those three groups to try to tie this together. What I think you'll see in the future are these three organizations working closer together on their own, and I'll let Bill.
Yeah, actually, that's a great question, and one of our strategies is to not duplicate effort, and particularly not drive the communities apart to make people force people to go to one or the other, or more importantly, have to go to both. And so we actually do work and are diligently working towards a much tighter relationship with the TIP organization. When our last meeting was here, 2 weeks ago? We met with their executive directors from London. He was here, spent a day with us. We have gone through the strategies. Archana, our community manager, is literally working with our legal counsel to understand cross-licensing between the two organizations. We have different IP policies. They license a lot of their projects under a RAND or RAND-Z. We use an OWF license. There's a lot of implications to sharing because of those. And we are trying to work through that with the goal of having, when the TIP organization and their community documents a need, and that need is fulfilled by a company like Edgecore, that fulfillment or that recognition of that work effort should be the same. I mean, TIP should recognize that outcome, and OCP should recognize that outcome. And you should be able to go find it as an OCP product or go find it as a TIP product, and it comes from the same person. It's marketed, it's shared, we're collaborating together. If we make changes to it, we go back to the originator, to work on that. So we don't want to duplicate efforts.
Now, regarding duplicated efforts, I think there are 3 or 4 different consortiums working on Open RAN. One of them is TIP, and one is the Open RAN Alliance.
Yeah.
How can you avoid duplication there?
Well, that's a great question. ORAN, so on the hardware side, one of the big...
4 different specs.
So on the hardware side, one of the big drivers is China Mobile and AT&T. We literally have calls every week with both of those organizations. Again, trying to understand how we not duplicate the efforts, how ORAN, again, in ORAN, their licensing scheme is different. When the Work Group 7 produces a specification, it's only available to those Work Group 7 members. We're trying to understand how we up-level that, make it available to everybody, that we have a common spec, and that we can then articulate that spec and source it through our community. So trust me, those are conversations we're having literally every week.
All right, thank you very much.
Yeah.
And
unfortunately, I wish there was a lot more things that we could report on. I'm hoping to make a couple of announcements. Yeah, no, we do. We have very formal meetings on a weekly basis. On September 26th, we hope to announce some of that. So,
by the way, the next speaker is going to be from TIP, Telecom Infra Project. So you can ask that question again.
So I think the question is, where do you draw the line? If there's one between TIP and ONF, OCP and TIP. I mean, are there certain areas where OCP should be, like from an ONF standpoint, where do we look? Who do we look?
Well, that's a good question.
I'm asking for.
Yeah, that's a great question. Where do you draw the line? I think, we came from the data center and kind of working our way out. TIP is coming from your traditional infrastructure, and they're adopting, a lot of the hyperscale hardware. Right now, the primary differences is around, they're focused on the radio network. We're focused on, wireline and that, and networking. Obviously they're going to cross somewhere in the middle. Our IP policies are different. And I think our community is different, the composition. And I think that's what it really comes down to is when you have, if you have a radio network engineers, they're going to be naturally gravitate to TIP. And there's a lot more work that goes on, R&D work and investment work at that level. And a RAND or RAND-Z license is probably more appropriate, for that organization. And, we have been able to work effectively with a completely open, ONF license that doesn't require, any secondary licensing, and we'd like to continue to do that, and figure out, where those intersects are to try to avoid overlap. So it's not it's still a little fuzzy answer, okay?
So from the ONF perspective, as all of you understand, I hope by now, that we are doing open source software. And we use the right hardware, which is ideally open spec. That you, as an operator, tells ONF, we are an operator-led organization. The operator says, I'm going to use a radio, which I would like to come from TIP, the 5G NR project. We write our software to write to that spec. If on the other side, Trellis, they said OCP certified switches is what we want to use. That's what we go with, or the OLTs from OCP, that's what we go with. So it is really a top-down, what the market needs, what the operators need, is what we base our exemplar platform specification on. Doesn't mean that you can not take that software and adapt it to any hardware you want. If that's what you want, you can do that.
Yeah, and you won't see us set up test labs and creating these recipes. We'll simply, use the ONF recipe. Because again, that's driven by the operators. Ultimately, they're the customer. We need to listen to them. So we will align with those organizations, align with the test labs that are going on, and provide support to that.
All right. Any other questions? All right. Thank you very much to Edgecore and Jeff.